Here recently, I've been giving you some SAT warm-up problems, so I wanted to just kind of go through those and make sure that you understood how the answers, or why the answers were the way that they came up to be. So the first one that you had was this picture, and they talked about point B that was on the segment AD, and eventually they wanted us to figure out what was the value of 3x. The big thing here was probably this information, the fact that this is 90 degrees, because that means that these three angles together also had to be 90 degrees. So when you put all three angles together, you have the x and the 2x and the other 2x, that's all going to be equal to 90. So that tells me that x is equal to 18. However, remember they asked for 3x, not just x. So you had to take 3 times 18. And that's why the answer for that one should have been 54. All right, this one I thought was a little bit tricky, but they talked about the line y equals kx plus 4. They said k is a constant. It's graphed in the xy plane. If the line contains the point CD, where both of those are not equal to 0, they want to know what's the slope of the line in terms of C and D. All right, well, the first thing we had to identify was, okay, the slope. Well, which part of the equation is that? Well, if you think about a line, one of the constants is the slope. And if you look at the equation, that was the coefficient of x. So really, when they ask for the slope, they're asking you to solve for k. The other tricky part was they gave you an ordered pair, but it wasn't numerical. It was a variable for x, a variable for y. In this case, it was C and D. So I'm going to go to that equation. Instead of y, I'm going to put d. We don't know k. Instead of x, they want us to put in c, and then plus 4. So from here, it becomes an exercise in trying to solve for k. So I can do that by subtracting 4, and then dividing by c. So that's why our slope for the k value would be d minus 4 over c. All right, the next problem says a line in the xy plane passes through the origin, so it passes through 0, 0, and has a slope of 1/7. So they want to know, okay, which of the following are going to lie on that line? Well, some of you may have tried to graph it, which would be fine. If I were attacking this one, I would probably think about the equation of a line. And I'd use this equation and think about, okay, well, first of all, the slope is 1/7, so I know it's 1/7 x. If it passes through the origin, that actually tells me the y-intercept. So the y-intercept would be 0. So I'm really looking for this equation, y equals 1/7 x. So I might go through and test all the points and see which ones work. For instance, 0, 7. Well, if I put 7 in for y and I put 0 in for x, I look and see, is that actually true? Well, that one's not true, so I can eliminate A. If I put 1 in for x, that would be a 7 times 1, so that's 1/7. Well, that doesn't equal 7, so that's out. If I put 7 in for x, the 7th of 7 is 1. That doesn't equal 7, so that's out. If I put 14 in for x, the 7th of 14 is 2, and that's why this is the point that works. This one, they had a system of equations. They want us to solve for x and y. This is probably a good setup for elimination. I have to do a little bit of rearranging here, though. If I start with the first equation, I'm going to leave it as is. But the second equation, I'm going to try to get the 2y to match that 4y. So in other words, I'm going to multiply by 2. But I'm also going to rearrange. I'm going to put the x first. So it was negative x. I'm going to multiply it by 2. I get negative 2x now. It was 2y. I'm multiplying by 2, so I've got 4y. It was negative 19. I'm going to multiply by 2. I've got negative 38. Now I've got the 4y's that match. They're both positive, which means I need to subtract. So 3 minus -2 would be 5. 4y minus 4y is eliminated. -23 minus -38 is like adding, so that gives me 15. And I find out that x is equal to 3. I'm only halfway done though, because I need to plug that back in. So if I plug it into the first equation, I can now solve it. So if I work through the steps here, I get a y value that's equal to -8. So the solution, the x, y coordinates would be 3, -8. So that means if I were to have graphed those two lines, then they would have intersected at the point 3, -8. All right, the last one here. If x minus 1 over 3 is equal to k, and k is equal to 3, they want us to figure out the value of x. Hopefully this one wasn't too bad, because essentially we're just going to take this 3 and plug it in here, and now solve that equation. So if I multiply by 3 on each side, and then I add 1, I get my x value of 10. All right, so we'll continue to do some SAT warm-ups as we go through. Just want to make sure you understood where some of those answers were coming from.